mathematicians, let's talk about linear and nonlinear Diffy Qs. Let's write down some examples and then see if we see like some patterns, and then I'll kind of tell you how it's defined. Okay, so everything on the left here is linear. Write those down and take a gander at them, and then we'll talk about them in a second. And then everything on the right over here is going to be nonlinear. And why is this important? Well, because when we go to solve a differential equation, you're going to look at it and you're going to characterize it, and that's going to decide what method you're going to use to solve it, right? And so certain methods you can use when they're linear. Okay, and so what's the difference of these? Okay, so in all the linear, you're going to see the dependent variable appears in first power only. Okay, so here our dependent variable is our x, right? And this really does appear in the first power only, right? I don't care about this t. This t can be anybody it wants to be, okay? But the x needs to be in first power only because the x is the dependent variable. Here, dependent variable, y, first power only. Okay. Here, dependent variable y, first power only. Okay, I know I highlighted this d here, but I regret it. All right, I didn't want to highlight that. Just look here. Look how it has. It's got no guys here. Okay. Likewise, oh yeah, hopefully it'll have a bad one over here. Okay, so nonlinear, right? Nonlinear y, well, this y has this 3 here. Nonlinear y, because I have a y here and a y there. Okay, nonlinear y, because I have those two. I'm going to give some more examples of nonlinear. Cosine y plus ln y. Put a little y there. This would be nonlinear. Who else is nonlinear? Of course, oh, you're like, Beth, you don't even have a derivative there. You're right. There, I made one. There. Put a little dy dx there. That's nonlinear. So, I mean, you guys know what a line is, right? Right? Y equals mx plus b. So all of our nonlinear friends, right, are our parabola, right, when we have our x squared, x to the third, things like that, right? Those are our nonlinear friends. And so, like I said, it's just kind of important to be able to look at the equation and be like, oh, is this linear? Is this nonlinear? And then what does that mean for the methods I can use to solve it? All right. Most equations are nonlinear because most equations aren't easy, right? Most equations aren't neat and clean, but we do start with linear because they're easier, right?